it is absolutely important that you understand absolute value equations. I talked about these in a previous video very briefly, just going over the concept that whatever's inside some absolute value bars, whatever it is, make it positive. So then, -5. Okay, whatever it is, make it positive. Cool. This is how you do it with simple numbers like this. But you can actually set up equations with variables and then solve them. So you kind of have to think somewhat backwards when it comes to these. So let's say instead you now have the absolute value of x equals 3. What values for x make this statement true? Well, x can equal 3, right? Because you put x equals 3 into here, and then 3, make it positive, turns into 3. But it actually has a second answer. This is the first time that we see an equation, but it has more than one answer. And you can see you plug in -3 in for x, and then whatever it is, make it positive. So absolute value of -3 is 3. A shorthand that you'll see is this equation can be rewritten as, well, the possible x's for this statement is equal to plus or minus 3, like positive or -3. This is shorthand for exactly this, that x can be +3 or x can be -3. That's all this is. Now, as I said before, the absolute value bars are kind of like a special form of parentheses in the sense that it's still holding order of operations away from it until you resolve everything from it. Or you can break apart things outside of the absolute value bars using the, inverse operation and properties of equality and whatnot. So for instance, for absolute value of x equals 20, and I wanted to solve for x, well, I would simply divide both sides by 4. Absolute value of x is equal to 5. X is equal to two separate numbers, plus and minus 5. So that's just anything that's outside of the absolute value bars. You kind of treat it as parentheses at that point, except with a negative component. But what about expressions that are not fully simplified inside those absolute value bars? How do we go about algebratizing those? X plus 1 equals 3. So we know that, well, what numbers would work for this? Well, 2 would work. That's easy enough. But not -2. Because if I put in -2 into this, I'd have -2 plus 1, which is -1. And then absolute value of -1 is +1, which is not 3. So it's not like a plus or minus deal just like this. But the concept of having a positive and negative answer to extract from those bars, that concept still holds. So what we're going to do instead is say that the entire expression that's inside the bars is equal to plus or minus 3. But that still doesn't look good because we still haven't solved for x. That's what we're trying to do with algebra, is isolate the variable. So this doesn't look good because then I try to subtract 1 on both sides. How do I know which one to use? It's both plus and minus 3 at the same time. We're not doing quantum mechanics. So the better way to go about this is to literally split up this here into just 2 separate equations and then work on them separately. So x plus 1 equals 3. X plus 1 equals -3. So I'm kind of splitting this up kind of like this. This isn't like a no and yes, I just picked 2 random colors. Then we subtract 1 on both sides over here. to get the x equals 2 that I had over here. But then we have our kind of, I don't want to say mystery number, but something that's not as obvious looking at this. It's going to have to get somewhere to -3 on the inside. So -4 plus 1 is -3, but then I have to start thinking about negatives, and that can get counterintuitive. So it's just easier to go about it this way. -1, and yeah, there we go. There's our x equals -4. Applying this concept, and then just the definition of it in general should give you a good head start. There's things to do with absolute values with inequalities, but they work the same way as long as you follow that one little inequality caveat. There's one more thing that actually kind of breaks math. You cannot have the absolute value of something equaling a negative number, let's say, -3. I know that I just said that removing the absolute value bars algebraically makes the answer into the positive and negative of it, so that why should it matter if the answer was negative or not? The answer is going to be the plus and the positive and negative kind of components, I guess, of that original answer. But that was based on the fact that that original answer itself was positive, because this was the definition of the absolute value, was that whatever you plug into it, you make it positive. This question is asking, what can you plug into the absolute value bars to make it +3? But down here, this question is asking, what can you plug in for x for it to become -3? This does not mean that this turns into what we were just talking about. This question doesn't have an answer because it's not a good question. It's not a question. It's a question that defies the definition of the thing that it's asking. So what we'll say is that the answer does not exist. That there's no solution. Maybe solution like that. If you want to use like set notation, like when we're using the curly brackets and whatnot, you would just say that it's the empty set, which is just a circle with a line through it like that. This is saying that this is the set that specifically has no elements in it, meaning that there are no numbers that when put into this equation would make this statement true. This is as bad as dividing by 0.